Okay, I'm going to be covering in section 8.4 problem number 12 as just a practice for you to see all the steps. So section 8.4 number 12, what I'd like you to do is stop this recording, go find that, read through it carefully, and then start this back up. So as I've read through it, it talks about the weights of discarded plastic from a sample of households. So obviously we're given sample data. It says in the summary statistics are, and I'm just going to write these down so I have them in front of me. N equals 62. X bar, which is the sample mean, is 1.911, and S is the standard deviation of the sample, because it's S, 1.065, and these are in pounds. X bar and S are in pounds. It says to use an alpha level of 0.05, so in step 1, I'm going to say alpha is 0.05. And I know in step 1, which you all should know by now, I have a null and an alternative hypothesis. So it says use alpha 0.05 significance level to test the claim that the mean weight, mean weight of discarded plastic from the population of households is greater than 1.800. So that's going to be my alternative because it's greater than 1.800. As you know, the null is always equal to, so that's going to be equal to 1.800 and an alpha of 0.05. Okay, so there's step 1. This is my claim, so I'm going to put an asterisk next to my claim. Okay, step 2. Since we're testing population mean and we do not know sigma, so we do not know sigma, all we know in this problem is about the sample data. So since we don't know what sigma is here, we need to use the t-test. So in step 2, I'm going to write down t equals x bar minus mu gets divided by s divided by square root of n. Okay, so remember you have to write the formula, then I'm going to fill in the values. X bar is 1.911, that was given in the problem, minus mu is 1.800, that was given in the problem, divided by S, which was 1.065 given in the problem, divided by square root of n, square root of 62 given in the problem. Okay, so now what I'd like you to do is stop this recording and go ahead and find out what that value is. Again, be careful. This quotient in the denominator needs to be in parentheses as you put it in your calculator, so it gets divided into the numerator. Okay, so go ahead and calculate that and then come back, and you will hopefully get that t, I don't know what happened there, something came up on the screen, that t equals 0.821. Okay, so t equals 0.821. Hopefully that's what you got. If you didn't, stop this, keep practicing. Okay, so that's what you got for your sample test statistic. Now what we need to do is find out what should we get critically according to our alpha level. So draw your T-shaped curve, which is just like your Z. Okay, we have N is 62, so our degrees of freedom is 62 minus 1, which is 61. And we have a one-tail test because we have greater than. Okay, one tail. My pen's acting up. And we have our alpha of 0.05. So go to your t-table and look vertically on the left for a degrees of freedom of 61. You'll notice that we don't have every value on our table that comes with our book. They are available, but on this one-page summary, we don't have that. So if you look it up, what you'll notice is that you go to 60 and then it goes on. So since we're at 61, we'll use 60 since that's the closest thing. So again, on a normal table, it would have everything in it, but on ours, it's just a consolidated table, so we'll have to use 60. We go across the top, and we see across the top that we have to use a one-tail test and alpha 0.05. So find that, the top row, one tail, 0.05, follow that down vertically until it intersects with the 60. And what you should find for your critical T, and since we're a right tail test, remember it's going to be over here on the right, our critical T comes up to be 1.671. And in our value, we got 0.821. So if you think of it, 0.821 is to the left here, and it's going to be in the clear. So since 0.821 is less than 1.671, we will be in the clear and we will accept H naught. Okay, so since 0.821 is less than 1.671, we accept H naught. So go back up to your step 1, you accept this H naught, so you are going to reject H1, which is your claim. So before I clear this page and move on, let's remember that we're going to reject our claim. Okay, so I'm going to get ready to clear this page and move on. And I'm going to write myself a note here that we rejected our claim. Okay, we rejected, oops, let me just say we rejected our, oh, I keep getting the, we rejected our claim. Let me do that. Okay, we rejected our claim. So now what I need to do is I need to write that out for step 4. So here's step 4. You didn't have to write reject claim. I just did, so I reminded myself. But step 4, if we're going to reject the claim, remember, we start there is not sufficient evidence to show that, and then we go back and we're going to word our claim. So I go back to my problem, the claim, to test the claim that, so to show that the mean weight of discarded plastic from the population of households is greater than 1.800 pounds. Okay, and you are now done with that problem. I do want to mention one other thing, so I'm going to clear this page and just remind you of one other thing here. When you have a left tail test and you're looking up the T, make sure you give it a negative. Our table only shows positive values. So technically, since it only shows positive, the other side would be negative since it's symmetric. But we have a consolidated table. If your alternative is greater than, then you can just keep the T positive. So the T will be positive as you get off the table. If you have a two-tail test, so remember not equal, so if you have a two-tail, you must make sure you give the T a positive and a negative, so plus and minus. So you'll have two T values, critical T values, so you'll give one a positive and one a negative. So I just wanted to remind you the table only gives positive, so you have to make sure you assign a negative if it's less than, or you will also take another negative on top of the positive for a two-tail test. If it's a one-tail test like the example I just did, then you're good to go. You just take the positive right off the table. Okay, so T's are a little bit different, but not too bad once you get the 4 steps down. All that changes is that step 2 a little bit, and then we have to adjust according to what that is. In this case, it's a t. Okay, so that's an example. So now you should be able to finish the rest of your problems.